My name is Taissir Boukrouba. I'm an intern at the Sparks Foundation for Data Science and Business Analytics Internship. This video is an overview of the second task, which is trying to predict the optimum number of clusters on the iris dataset, which is a flower dataset, and represent it visually. For the model, we're going to use the k-means algorithm, which is an unsupervised learning algorithm, which is our case, since we want to get specific number of clusters, because there is other algorithms where we don't specify the number of clusters or where it is not important. So for the steps, we, as always, import the libraries, load our data, pre-processing, evaluate, and model iteration, and then we visualize our data. Let's try to explain what our dataset has. So it is an iris dataset, which is a flower. As you can see here, there is 3 subcategories: iris versicolor, iris setosa, and iris virginica. The objective here is we are trying to use the measurements given in this data, which is of the leaves, which are the petal and the sepal, length and width of each of those, and try to create clusters which represent these subcategories. So we import the libraries. We have pandas SPD for data preprocessing, matplotlib for visualization, k-means, which is our algorithm, and seaborn, which is another plotting algorithm. It is a little bit more sophisticated than matplotlib. So as for importing our data, we can see that we have 150 rows and 6 columns, 150 instances. When we investigate the head or the initial values of these data frames, we can see that there is an index, the ID, which is pretty much the same thing, sepal and petal length and width in centimeters, and the species, which is the categories or clusters we're trying to predict. So as we can see here, there is 50 instances of each subcategory, and we're going to drop the ID because it is not as useful, since it has very high cardinality, which means our model can't see any pattern through the ID. And the species will be dropped since we are going for an unsupervised learning. So the model will try to predict those. Afterwards, we have data preprocessing, where we clean our data, meaning we look for missing values and clean them if found, and we transform all the categorical variables into numerical values in order for the model to be able to use them. Our data is clean, as we can see here, no values, and all of our data is numerical, as we can see here, float 64. Afterwards, we try to evaluate or get the optimum number of clusters. There is a method here in the k-means for the k-means algorithm. It's called the elbow plot. Basically, the elbow plot is an evaluation method which gives us the optimum number of clusters based on the within cluster square of sums, which is the sum of Euclidean distance between the data point and centroid squared. Okay, let's try to simplify this. So basically, k-means tries to go through our data points and see the similarities between each data points, and then it creates a group, or what we call cluster. Each group or cluster has a center, which we call centroid. This center will help us evaluate these clusters. So basically, the within cluster square of sums is the sum of the distance, which is the Euclidean distance between the data point and its center. Then we sum them and we square them to get this this evaluation value, which is the within cluster square of sums. We'll go over this to see how does this works. So the more number of clusters, the lower within cluster square of sums. But with the elbow plot, we can get the optimum number, which lays in the elbow of the plot. We're going to see afterwards how we're going to get this. So, as you can see here, going before the elbow means less number of clusters. Here, as we can see, here is the elbow. Going before, there is only 2 or 1 cluster or group. And more within cluster square of sums, WCSS, where the data points will be far away from the centroid, since there is no much centroids. Basically, or simply, when we go before the elbow, there is only 1 or 2 clusters, meaning only 1 or 2 centroids, which will get most of our data will be far away from the centroid. But if we go after the elbow, there will be more centroids and more possibilities. We'll go over this and see it. So going after the elbow means more number of clusters and less in distance. The distance will be less between the centroid and the data point. But there is a curse, of course. If it keeps going until the number of clusters equal the number of data points, then each data point will be centroid itself. Let me explain it. So if we have, for example, 9 data points, and we say we do 9 clusters, meaning each data point will be cluster, since each cluster or group has to have a centroid, so each data point will be its own centroid. The distance will be 0, but that's not what the optimum number will look like. Meaning, like this, our model will do nothing. We'll just give each data point a cluster. But the optimum number is the elbow. As we can see here, the plot imitates the human hand, and we see here the elbow, which is in this case 3. So 3 is the optimum number of clusters. Here we are initiating the K-means algorithm with 3 number of clusters, which is the optimum which we find, max iteration, etc., random state to shuffle our data. And here we get the predictions given by the algorithm. So we'll try to visualize these predictions or these results in order to understand more. So here we created a scatter plot, and we try to color each cluster differently with each centroid also of each cluster. So we have here 3 clusters. First cluster here, we use the by the way, we use the petal width and petal length as inputs here. 2 and 3, we didn't get all of our data. It would be more than 2D. Here, petal length and petal width. These are the only features that we used for this case. So yes, we have petal length and petal width. Here we have first cluster, the second cluster, and the third cluster. In order to be able to annotate these clusters, I have used You can use whatever you want, whatever visualization is convenient. In this case, I have used the box plot for the petal width. To use the petal width, as we can see here, the least petal width is for the iris setosa, then iris versicolor is the medium one, and the last one which is iris virginica. And finally, to answer task's main question, which is the optimum number of cluster, as we saw before in the yellow method, it is 3. So this is it, and thank you.